Hello everyone, hope you all are doing great and welcome back to this new video series where we are going to be creating weather app using SwiftUI and Mvvm design pattern. Okay, so first before we talk about what you're going to be learning, let's go ahead and take a look at the app. So app itself is basically this weather app that shows weather for the location searched. So you can search for a location and it'll show you weather details. So for example, we have this today widget which shows you what's the current conditions are for various different features like humidity, chances of rain, wind, current temperature, current weather. It also shows you hourly weather. So basically, how is it gonna look like throughout the day, hour by hour, for next 24 hours. Okay, so and if you notice, it actually displays the time as well as the temperature. um, okay, and then you also have an option to see what's coming up next 7 days. So how's the weather gonna look like for next few days. So you're going to be rendering all this information and basically going to be displaying that on the screen. Now, if you notice, we are using some animation for this weather condition right here. And if you, for example, change this, so let me change this to Japan, for example, and I'll search for Japan, and the weather conditions are going to change according to what the weather in Japan is, and based on what's going to be what time it's going to be and stuff like that. If I change this to Paris, maybe, um, then you're going to see different animation and different weather conditions. um, Okay, so yeah, so this is what we are going to be building. There's a whole lot that you're gonna learn, and just for creating this simple screen, there are so many things that you're gonna do. So it's exciting to basically see and learn all these things. So let's go ahead and take a look at what the learning objective for this video course is gonna be. So first of all, we are first and foremost, we are definitely going to be learning about SwiftUI. We're going to be learning about view composition. Okay, let me add a few more things. Actually, there's Swift Package Manager. So we're going to be using that, and we're going to be using date and time formatters. Okay, all right. So yeah, so we're going to be definitely learning about SwiftUI. We're going to be learning about view composition. So basically, when you have various different views, how to combine them in such a way where they have each of them are separated in its own entity, and then you combine them together to build something like complex like this, right, where you have all the weather information, animation stuff is going on. You have a horizontal stack that's actually displaying these hourly, and then you have a list that's displaying daily weather forecast. Okay, so yeah, so you're going to be learning about view composition. You're going to be learning about using UI kit components in SwiftUI. So we're going to be what we're going to be doing is for this animation, we're going to be using Lottie animation, and Lottie is something that provides a way to animate these JSON files that designers can create animation in, and you can control this animation using your code. Okay, so that's Lottie, and you're going to be using Lottie. So Lottie at this point does not have any SwiftUI component. So what we're going to be looking at is developing our own component out of the component that is available in UIKit. Okay, so we're going to be building UIKit based, we're going to be using UIKit based solution and importing it or transforming it into SwiftUI. You're going to be learning about Mvvm. Although this is a simple UI, so it's just going to have one screen, so there's going to be one view model, but that view model is going to contain most of the logic that our views are going to deal with. So you're going to see how you can actually use Mvvm to sort of separate out the logic or the brain of your app. And along the side, you're going to also learn about using combine to basically publish and observe asynchronous responses, and we're going to be using that for downloading data from the network and publishing that data so it's been observed for the changes. Now you're going to learn about passing observable and observed objects, so various different layers of your view can use that published object without resubscribing to them, using same published object. Okay, so you're going to be learning about that. You're going to be making network API calls, of course, because this data is coming from the internet, and we are going to be using Open Weather Map, one API, a network call, to basically make this network call and get all the data. You're going to use result type, so instead of returning a returning an object, you're going to be returning a result type, and that result type gives you flexibility. What happens in case of failures, what happens in case of error and success and stuff like that. So that's a new way to handle all the async results, and you're going to be learning about those. Lottie animation, like I mentioned, we're going to be using that. We're going to be fetching coordinates from address. So one API that's actually provided by Open Weather Map uses coordinates to find out the weather. So when your user searches the name, a place's name, then how would you take that and convert it into coordinates? So you're going to be learning about how to make that translation, how to fetch latitude and longitude information for a given address or location. You're going to be using Swift Package Manager. Swift Package Manager again is going to be used for Lottie. We're going to be including Lottie package. So instead of using CocoaPods, you're going to be using Swift Package Manager to see how easy it is to include that, and your project structure doesn't get modified and stuff. So several benefits there, and how seamless it is to include it in your project. You're going to be learning about date and time formatters. So if you look at this data, you're going to see you have a full date, then you have just the time, then you have just the day. All these are just coming from the same date field that we received in the API call. So we're going to see how we can transform a date into various different formats and use them within our app. Okay. So with that, we are ready to jump right in and start creating this project from scratch, and basically learn all about all the things that we discussed in this video series. I hope you're excited as I am. So let's go ahead and hop right in. All right, so what I've done is I've created a new project, and it's a brand new project, so there's literally nothing into this. So if you look at the content and everything, it's just a boilerplate code. So that's what we have, and what we're going to do is before we look into before we start developing or putting together our app, we want to see where the response is going to come from, because I guess networking should be the first thing that we should tackle, because then we would know what all models we're going to need, and then we can start creating our views based upon the model responses that we get. Okay, So let's go ahead and take a look what we are going to be using. So we are going to be using Open Weather Map, like I said, openweathermap.org, and its API is free. All you need to do is basically register yourself for an account, and then you would be able to uh, get yourself an API key, and that API key would work for your network responses. Now we are going to be using specifically this one called One Call API, and One Call API is basically a single call that actually returns you result like the response about all the weather conditions. That includes hourly, minutely, daily forecasts, and the current temperature for a given location. Okay, so if you go into this URL, openweathermap.org slash API, so you're gonna land right here, and as you can see, there are various different um, API calls that he can make. So it's a really rich API, and this one is my favorite one call API, because this gives you all the information in one response. So you don't have to basically make multiple requests to basically get weather information or forecast information and stuff like that. Okay, so I would encourage you to go through the API one time to understand how it's laid out and how it's structured. They have like a really nice example at the bottom, and let's take a look at an example of our own. So the network call that I made using my API key, and the response that I got. Okay, so this is what your response is gonna look like. Once again, I'm using a JSON Prettify plugin for making this JSON look a little bit more structured. But this is what we have. So we have latitude, longitude, time zone information for given latitude, longitude, time zone offset. Then you have current conditions. So if I collapse these, you're gonna see these are the things that I'm actually I'm getting, right? If you look at the URL itself, you have your latitude, longitude, and you have exclude, which is basically something that you can use if you want to exclude any of the field from the response. So for example, I'm not interested in minute by minute forecast, so I have excluded that. So that's why I've included I've excluded is equal to minutely, and that's included in my URL request. This gives me an opportunity to just see what I want to see. So you can provide comma separated values here, so you can provide current if you're not interested in current, hourly, daily, whatever you want to do. Then you have your app ID, which is your API key, and units. I'm using imperial. That actually shows everything in Fahrenheit and imperial unit. Okay, let's take a look at the current weather situation. So if you look at the current, you get date, the weather forecast or weather condition is for your sunrise, sunset, temperature, feels like pressure, humidity. So there's a lot of data points. You also get weather with clear description. So you have you have main, which is a high level one word description about what the weather condition looks like, and a little bit more descriptive way of what it is: clear sky, number of clouds. So clear sky is number of clouds is going to be 1 or 2 or something like that. Yeah, so it's going to be there, and this is actually helpful if you're building for example, if you're building a UI that has animation, or you want to show clouds, reflecting the real value of clouds, and as a part of a background, you can actually use this to say if there's only one cloud, then you show one cloud animated, or you can have multiple clouds. So this actually can be quite useful. Okay, and just to see like different variation, I believe there is a place. Look at this, cloud value is 0, so there's no cloud. And I believe I saw one place where it was like about 100. So which was yeah, okay. So anyways, we can, yeah, you can take that as a challenge to complete on your own, to create an animation for the background. What you have in hourly is like something very similar. It's a collection of hourly weather forecast, and it includes like what the conditions are going to be with similar fields. There are a few things that are missing. For example, current has sunrise and sunset, and your hourly does not have sunrise and sunset for obvious reasons. But most of the fields are pretty similar. Okay, then you have daily. Daily is quite different. You have date, sunrise, sunset. You have a minimum, maximum temperature, night, evening temperature, morning, and stuff like that. What it feels like versus like what the temperature is, pressure, and other weather conditions are also there. Okay, so you can use this information to basically create your experience however way you want to. So look at this. Yeah, this is the cloud 100 that I was talking about. So yeah, so basically you can create a UI however you want to. So it's like a rich information that you can use. So we're going to be using all these. We're going to be using daily, we're going to be using hourly, and current weather conditions as well. Okay, so that was about the API itself. And then, yeah, so I guess the first thing is to go get yourself an account, and then we're gonna start structuring our code. So we're gonna start creating our code structure for folders for our app to live in for different components, and then we're gonna start working on our networking layer. Okay. All right. So let's go ahead and um, get our folder structure set up. So I'm going to create a few folders here. So first one I'm going to create is going to be helpers. And this actually is going to comprise your network manager, your API extension, stuff like that. So you can even name this networking actually, because most of the stuff that's going to live here is going to be networking related. Okay. Um, then you're gonna need something to store your models in. So models. Um, we're gonna need one for views, one for view models, and I'm gonna use one more, which is gonna store our Lottie animation files. So I'm gonna call it Lottie animations. Okay. Now Lottie animations is something available for free on lottiefiles.com. So I'll show you like when we get to the point where we need these animations, and I have a certain set of animations, so you can actually download those from the website itself that I'll show you. Okay. All right. So I guess the first thing is let's go ahead and get ourselves a networking layer. And so what we're going to do is we're going to create a few files. So first file we're going to create is going to be API itself. Okay. Now this API is going to be storing the API key. So let's go ahead and create a struct. We're going to call this struct API, and it's going to have one field which is going to be key. Okay, and this is where you're going to include your API key. Okay, next is basically another file that you're going to create, and this file is going to be called api.extensions. API plus extensions. So there are a few more things that you want to do in the API. Now I want to create two different files for API. Reason is because I want to keep my API secret for obvious reasons. But this is how you can actually segregate your code, having API key in one place and having rest of the stuff that your API does in an extension. That way, whenever you're checking in your code, you can remove the API key and prevent it from being exposed. That way, like, you save your credentials and you keep your credentials safe. Okay, so what we're going to do here is we are simply going to write an extension for API. Okay, and it's going to have a first of all, it's going to have a base URL. Okay, and this base URL string is going to be our openweathermap.org base URL for the API. So I'm going to copy and paste that. It's https://api.openweathermap.org/data/2.5. That's the version that they're running right now. Okay. Next, we are going to create a static function that is going to give us a URL. Okay, so we're going to say static func get URL for lat, which is going to be double, lon, which is going to be double as well, and this is going to return a string. Okay, now this string is going to basically construct a URL. So we're going to use string interpolation. First, we're going to take our base URL string. Okay, and it already has a slash here. So after that, I'm going to say one call. Okay, that's coming from the API itself. So we're going to use that. Then we are going to have query string lat, and this is going to be the latitude that is provided. And for another query string, lon is going to be lon value or long value that's provided for longitude. You're going to have exclude. I have this extra and exclude. So thing that we want to exclude, or like the response that we want to exclude from our API call, and I would say minutely. So that's minutely we're gonna exclude, and then you're gonna need your API key. So app ID is what they call it, and we're gonna supply our API dot key, or you can simply say key. Okay, because it's part of the API itself. You're gonna have units, and units is basically we're gonna use imperial. So let's define imperial. All right, so that is going to be our base string. Okay, or basically the URL. And every time we actually search for a location to display the weather, then we're gonna supply the latitude and longitude information, and then we're gonna get the URL back for that latitude and longitude along with API key, and we're gonna use that to make our network call. Okay, so our API related stuff is ready. So what I'm going to do is next let's create our network manager, and I will populate my API key for this in this file, and you go ahead and do the same thing so we don't end up like getting an error when we make the API call, because it's not going to be because API key is not found, then it's not going to return you any results. So we're going to do that, and then we're going to create our network manager. Okay. All right, so I went ahead and populated my API key. Now it's it's populated and collapsed, so we are ready to go. I hope you are too. So let's go ahead and create another file. So I'm going to hit Command N and create a file. We're going to call this file Network Manager. So let's select Swift file, Network Manager. And this is where our network manager is going to live. So we're gonna simply create a final class, network manager. Okay, and this network manager is going to be generic type, and it's going to have a generic constraint for codable values. So it's only going to contain, or it can only be created with a generic type that conforms to codable protocol. Okay, then we're going to create a static function which is going to be called fetch for URL. So we're going to expect our caller to supply a URL that needs to be called, and it's going to have a completion handler, okay, which is going to be escaping, and it is going to return a result. Now this result type returns a type, so we're going to say T is going to be the type that's going to be returning, or network error. Now, network error itself does not exist at the moment, so let's go ahead and finish this, and we're gonna create an enum called network error, which is going to be extending or conforming to error protocol. So we're gonna create enum network error conforming to error protocol, and we're gonna have three cases. We're gonna have invalid response, we're gonna have invalid data, and we're gonna have error, which also will have associated value of string type. Okay, so now our error will be gone. Okay, next we're gonna create a URL session and data task. For the URL session, we're gonna make the API call, and then we're gonna return that result in our result object. So in our result type, right? So we're gonna simply say URL session dot shared dot task. So if you type task, you're gonna see a few variations. So there is one that takes a data task, and it takes a URL and gives you a completion handler. So we're gonna use this one, and we're gonna simply say supply the URL that's being passed by the user, and what we get is a completion block with data, response, and error. Okay. Now, before we forget, let's type resume so we can initiate our network call. Next, we're gonna put a guard statement for error. So only proceed if the error is nil. If it's not, then we need to return from here with completion stating that the network API failed due to an error, and we're gonna actually use error block or error type that we have created, right? Network error with associated value to basically provide the details. So we're gonna simply say error dot localize description. You might want to print your error here as well, just to give you a better idea what happened. Okay. And yeah, so that's going to be your error type. Now let's see, you can actually do string describing error, and we know error is not nil, so we can force unwrap that. Okay. Now next we need to get when we get the response, is not of type HTTP URL response, so we need to convert that, and that conversion also can fail. So we're gonna simply put a guard statement here, guard let HTTP response. So we're gonna take our response that we have, and I misspelled this, so response as HTTP URL response. Okay, and we're gonna try to get that, and we're also gonna check if the status code on the HTTP response is 200. That means we are actually getting some sort of result. If it's not, then we do want to return from here, and we also want to provide a completion with failure, and we want to say this is case of invalid response. Okay, we're also gonna create one more guard let for data, so we can safely unwrap data that's been given to us. If it fails, then we want to reply or call the completion block with failure invalid data, and we're going to return from here. Now, if we have passed through all these guard statements, that means that we have some sort of data. So we can say do let JSON try JSON decoder, and we're going to try to decode something. Now, this something is usually a type that conforms to codable protocol, and that is the intent why we are restricting our network manager to be called in only by the type that conforms to codable protocol. So we can call this here. So we can say t.self, and this is basically going to decode as long as the object that we are passing is codable conformant. Okay, and we're gonna pass data here. Okay, and now here, this is the time where we're gonna call our success finally, and we're gonna supply the JSON back. Okay, and we're gonna also catch the error if there's any error while we are trying to decode this. And I believe we should create a case for decoding error. Okay, and we're gonna first of all print the error. So let's print it with string describing error. Okay, and we're gonna also call our completion with failure, and this time we're gonna call decoding error failure error dot localize description. Okay, and that is going to be our network manager, which is going to be responsible for making all the API calls. Now, as you already see, it's actually conforming to some type, so you don't need to know what type it is. So you can literally use this for any kind of network API calls as long as your object that you're calling on conforms to codable protocol. Okay, so now next up, we're gonna create our models and make them conform to the codable protocol. And these models are gonna be based upon the API response that we get from Open Weather Map. So we're gonna take a look at the response itself, the response JSON, and we're gonna construct our own object representing that JSON response, and then we're gonna basically make it conform to codable, and then gonna call network manager to get the data. Okay, so that's gonna be next. All right, so what I have is the API open, the call that I made using my API key on the browser to see what kind of response do I get for that one call API. Okay, so what you get is, if you look at the high level, it's a dictionary. It's a JSON response with key value pair, right? So you're gonna need something that actually wraps all your objects, your current condition, your hourly condition, and your daily condition. So we're gonna need one object for that. We're gonna call this maybe weather response, which is gonna contain the entire response object. Okay, next, if you notice, we have current, which is providing the current weather situation. And if you remember, hourly has the same fields except sunrise and sunset. right? So what we're going to do is we are going to create a weather object, and sunrise and sunset is something that we are not using in our app. So in case if you're using, what you can do is you can create a base class and basically have that base class sort of wrap or like provide these as default, and then create a subclass that can have all the other fields. That way, whenever you need current, you can call the subclass that includes these two. Yeah, or you can call basically, or okay, let me take it back. The way you're going to construct the object if you need sunrise and sunset is going to be, you're going to have a base class which is going to have common fields. So you can have common field which is like date, temperature, feels like, and stuff like that. Then you're going to create a subclass which is going to have just these two, sunrise and sunset, right? So use subclass in wherever you need the current weather conditions, and use uh, the the base class when you need hourly response. So I'll show you in the code how you can do that, although we are not going to do it, or we are not going to use that code, but I'll just show you the concept here. So that way you can have, like, one class handling both the cases. Then you're gonna have a response which is daily. Now daily type has a wrapped dictionary which is called temperature, right? So we're gonna need that for minimum and maximum temperature. So minimum and maximum, which is like, maximum is daytime, like in during the daytime, maximum temperature is gonna go, and minimum temperature which is gonna fall in the night. So that information we need. So we're going to create an object for this so we can handle this case, and we're going to create an object for daily weather because its structure looks a little bit different from all the others, although with more refactoring or structuring, like your code with inheritance and stuff, you can create you can work with single object. I'm not going to make it too complicated, so I'm going to create two classes, but if you feel like, go ahead and experiment with it. Then one thing that's going to be common for all is going to be this weather response, and this is going to be a weather detail class. So we can actually use that to parse our weather detail response, which is going to have this main for the conditions, the current weather conditions. Okay, so that's the plan that we're going to be using. So let's go ahead and create something for our models. So like I said, first thing we're going to do is we're going to create a new file for weather response. Okay, so let's wait for Xcode to respond. Okay, so we're going to say weather response. Okay, and this weather response is going to have a few things. So we're going to say struct weather response. Right now, this weather response is going to be conforming to codable protocol. Now we're going to have three things. So we don't need any of that. We are not using any of the time zone related information, so I'm just going to ignore those. So something that you don't need, you can simply ignore it. What you need, you're going to create those keys. So I'm going to create one for current, which is going to be of weather type. Now weather type does not exist for us. Okay, so I think it's a good idea before populating this to create the rest of our models, so we can basically start from there. So let me see. There we go. All right, so we're gonna create one class for weather. Okay, we're gonna create one for weather detail. And we're gonna create one for daily weather. Like I mentioned, I'm gonna keep two. And Okay, so we've got weather response, we've got temperature. We don't have temperature, so let's go ahead and create one for temperature. Okay, all right. So first, the lowest level is your weather detail. So let's go ahead and populate the weather detail one. So we're gonna create a struct weather detail. Okay, once again, it's gonna be codable, conforming to codable protocol, codable, and it's gonna have main, description, which is gonna be a type string, and icon for type string. Okay, so this is our main, our weather detail. Okay, then we're gonna have weather. So weather is gonna use weather detail. So let's go ahead and create weather struct. This is going to conform to codable. This is also going to conform to identifiable protocol because we need that in order for SwiftUI to recognize each record individually. So what we're going to do is we're going to create an extension here for weather, and this extension is going to have a computed property for ID, and this is simply going to return a UUID. Okay, so this ID is not passed by the service itself, so we're going to create that and we're going to make it computed property. That way Swift knows that while decoding, it doesn't need to decode this ID because it's a computed property. Okay, now we're going to use we're going to create our keys. So first one is going to be DT for date, temperature. So I'm going to just use all the others that are present in the API response. Okay, and then we're gonna have weather, which is going to be weather detail. So what's gonna happen, your codable is gonna see that, hey, there is weather object here, which is referring to a weather detail. So it's gonna go inside the weather detail and gonna populate that object. So you're gonna get that. And if you look at the response itself, the weather detail comes back as an array. So if you notice that weather detail comes as an array, so that's why we have created this object as an array of weather detail. Okay, and the key itself is called weather, so that's why we named it weather. Okay, now there are several other fields that are there. So what we want to do is we want to basically ignore those. So we have two options. We can either make these values, these keys, optionals, right? So if there is no value, like for like optionals, then it's going to be ignored and stuff like that. And like missing fields is not going to cause any issue. But what we're gonna have is we also gonna have some issue with ID. It may happen that we get run into some issue with ID. So what we're gonna do in order to avoid that, we're also gonna provide an enum for coding key. Now this gives you another opportunity. So although we're not gonna use coding key for the purpose of that other opportunity that I'm talking about, where what you can do is you can change these names. So you can, if you want, you can, so let me populate the first one and I'll tell you. So you can simply say DT here, and you can change this to like current date. Okay, so your weather object is going to have something called current date, which is going to be mapped to dt. Okay, although for our case I'm just going to ignore this and I'm going to use the name that we have received or keyed inside the response. So I'm going to use that, but in case if you like to change your name, please feel free to do that. It's that easy. It's just the key goes inside the double quotes and you say whatever you want to call this. So feels like, for example, equal to this is gonna work as your key. So feels like is gonna be the class object representing the JSON response key feel underscore like. Okay, now we're gonna remove all the types because all these are keys and they are of type. They're supposed to be of type string. All right. So with that, our weather object is ready. Now we do need one empty case. So what I'm going to do is I'm going to create an initializer, and we are going to basically create an empty weather for all the for all the values. So I'm going to initialize all the values with empty values, like date 0 because it's an int, temperature, feels like, and stuff like that. So temperature is going to be 0.0, feels like. So sort of we are creating a 0 state. Like so. Okay. All right. So our weather is finished. Let's fix this error. Okay. So our weather object is finished. Weather model is finished actually. And now we're going to go into our weather response. And we are going to create our weather response now. So let's go ahead and create for current. So var current, it's going to be of type weather. Okay. Var hourly, like I said, I'm going to use weather. So that reminded me that I need to show you the base class case. So if I wanted to use weather, and if I wanted to have, like, that sunrise and sunset values keys as well, then what I would do is I would create, and for that actually you'd have to convert it into a class, and you would create, or let's try with struct. I never tried with the struct, so I see subclasses. I don't think subclassing is possible. Let's see, we'll find out. It's going to be a good experiment. I never tried that. I think it's going to be, yeah, it's not. Inheritance from non-protocol type is not possible. Okay. All right. So what we're going to do is you're going to create this as a class. Okay. And make sure you don't create as a final class. It's actually going to be a class that is going to be extended, or you're going to have another subclass. So whether subclass, and you're going to create sub or sunset, for example, int and sunrise. I'm just going to use that example. So what you can do is this gives you an opportunity to go back to weather response, and for current you're going to stick to weather, or no, for current you're going to stick to weather subclass, and or you're going to create that, and then hourly you're going to have weather. So for hourly, when sunrise and sunset values are not present, then it's going to use the base class, which is weather, right? And when the sunrise and sunset values are present, then it's going to use this weather subclass. Okay, so that's how you can create that. So let me undo everything, because I don't want to use those in my case. And I'm going to do this too. Okay. All right, so our weather response is halfway done. We need daily weather. So let's go ahead and create or go to our daily weather file, and we are going to create a struct called daily weather, codable and identifiable. Okay, gonna create an extension to provide a computed property of type UID, and then so we don't have temperature creator, so let's go ahead and create our temperature struct, because we are going to need that. So let's go ahead and create struct. Okay, and now we are going to go back, and we are going to say for the temp is going to be temperature. For weather is going to be the weather detail. Okay, let's create coding key. So make sure it's coding key, not keys. All right, so let's see, we can run an initializer as well, and Xcode will catch up in a minute. We'll try to build case. Okay, that's not case, that's enum. That was my bad. Okay, let's go ahead and build. Okay, so let's go back to our weather response, and we're gonna need to populate our daily weather forecast as well, which is gonna be of type daily weather. Okay, all right, now we're gonna create an empty state. So I'm gonna create a static function empty, and we're gonna use this. This empty returns a weather response, and it simply returns an empty weather response. So we're gonna have for hourly, we're gonna have 23 different instances for next 23 hours, how the hourly is gonna look like. So I'm gonna create an empty object for that hourly, and for the daily case, we're gonna have basically 8 different uh, eight different instances, so 8 days of value is gonna have. So instead of, like, so we're gonna populate these with empty values. That way our values, whenever they're populated from API response, they're gonna just replace those. So there's not gonna be, like, shrinking or collapsing views that look like kind of ugly. So you're gonna have like values being populated in place. Okay, that's why we are actually doing this. All right, with that, our weather model, or all of our models, are actually ready to be used. So now all you need to do is, whenever you make a network API call, you pass weather response, because it inform or it um, conforms to codable protocol, is gonna basically successfully be able to or JSON decoder is gonna successfully able to decode all the response into weather response object. Okay, so with that, our this model creation is done. Next, we can go ahead and create our view model. And first, we're going to create view model. So we're going to have, like, all the computer properties inside the view model, and then we're going to start creating our views. All right, so let's go ahead and create our view models. So, or it's going to be just one view model in this case, and we're going to call this one city view model. So it's city view model actually. So let's name it city view model. Okay, and the city view model is going to be importing from SwiftUI. We are also going to import from code location, because we are going to be using code location to extract coordinates out of the address. So we're going to have that functionality written here as well. Now we're going to create a final class, because we know this class is not going to be the one that's going to create any subclasses. So that improves our compile time performance. So city view model, and it's going to be an observable object, so we can observe for the changes when they happen whenever our API returns a response. Okay, so we're going to create a published value for weather, which can be observed, and we're going to say weather response dot empty. So we're going to initialize with empty, and we're going to have a published property for city value as well, which is going to be of type string. Initial value, I'll provide San Francisco. We're going to have a did set, which is going to call a function that is going to get the location for. So call get location here. Okay. Next, we are going to basically create some of the formatters. So let's go ahead and create 3 formatters for date. There's going to be a date formatter itself. There's going to be day formatter, which is going to just give us the day value, and there's going to be a time formatter, which is going to give us just the time value. So okay, so this is going to be our date formatter. And we're going to use EEE, which is the date format, for returning 3 letters for the day. So that's going to be the day, and then you can have time formatter. and we're going to use one that's going to return only hour of the day and AM PM. Okay, so these are going to be our formatters that we're going to use. All right, next we are going to have an initializer which is going to call get location as well. So get location is going to be called here as well. So let me copy this and paste it here. So all we need to do is uncomment that. Okay, now some of the properties that we're going to need. Okay, so we are getting a weather object and we are publishing that to our subscribers, right? And what we can do in this view model is we can return a formatted response as well. So that's what we're going to do. First thing, we're going to return a date. So whenever somebody asks for a date, we're going to simply say date formatter dot string from date. Now, if you noticed in the response, or if you go ahead and look into the response now, you're gonna find that response is the date response is coming as a big integer value, and it's actually a timestamp. And timestamp is used using the time interval since 1970. So that's what we're gonna use. So we're gonna say date time interval since 1970, and this time interval part is going to be weather.current.dt. Okay, so that's going to give us the date, a formatted date. Now we're going to also use provide something for weather icon. So I'm going to create a string. So we're going to say if weather dot current dot weather. So this is basically going into that weather detail object. And what we need is basically from there, we need to first check if the count is greater than 0. So what's going to happen for the first time when the your UI is loaded, at that time your weather count is going to be 0 because there is no response that you have received from the API. It's going to happen on successful API call. So you want to check if the weather count is greater than 0. If it is, then we're gonna return. So we know, like, we want to return the first index. So 0th index dot icon. That will give us the weather icon. In case of default, we're gonna simply give it sun dot max dot fill. Okay. And okay, so we're gonna create a temperature object as well. A property. We're gonna actually create a helper function that's gonna get us the temperature. So let's go ahead and create a function get temp for temp double, so we can get the formatted response, and we're going to use time formatter dot string. Sorry, that is for not time formatter. This is simply going to be a string format, and temperature value is going to be percent. So we want to represent temperature with one decimal, one value, one fraction after decimal. So number of fraction, like digits that you want. So you can say that 0.1. F, if you want 2, you can just replace this with 2. Okay, so 0.1 F, and we're gonna supply temp here. So what we can do is we can use this guy to return our temperature value. So we can simply say get temp for weather dot current dot temperature. Okay, Now we're gonna have something for conditions. Conditions is going to be the same check. So we're gonna have, if the weather count is greater than 0, we are going to return main for the conditions. So it's gonna basically say whether the weather is clear, cloudy, and stuff like that. Structure, like some structure. There is a structure that the response itself gives you. So let me show you. Okay. So we get inside the weather detail, we get icon and main, which is one word description what the weather is. So you can use that, or you can use the description if you like. So we are going to use the main, basically the one word description. Okay. All right. Now next we're gonna create something for wind speed. Once again, 0.1f percent percent. Okay. And this is going to be weather dot current dot wind speed. You're gonna get the humidity. Now humidity is going to be displayed in integer, so it's an integer value, so we're going to use %d, and we want to show percent sign, so we're going to use double percent to show that percent sign, and this is going to be weather dot current dot humidity. Rain chances. So rain chances value is double, so we're going to use, we don't need any decimal points value, so we're going to simply say 0.0f and double percent to show the percent, and this is going to be weather dot current dot dew point. Okay, we're gonna create a few more helper functions. So we're gonna create one for time, so get time for timestamp. It's going to be an int value, and we're going to return a string. This is where we're going to use our time formatter. Okay. All right, and then we're going to use something for day. So basically, this is going to be another formatter. We're going to use our day formatter. So get temperature is done. Now let's create get day for. Okay. All right. Now we're gonna use basically our a CL location or geolocation value to get add the latitude and longitude from the address that's been given to us. So what we're going to do is first we're going to create a private function get weather, which is going to take coordinations, so CL location coordination 2D, coordinate 2D, not coordination, coordinate 2D. If let coord is equal to coordinates, right? Then we're gonna construct our URL string first. So we're gonna say api.get URL for latitude longitude. Okay, and sorry, not if let, just let. And then we're gonna call a function for weather information. This is where we're gonna make our network call. So let me go ahead and create that function first. So private get weather internal, and this is going to basically be supplied with a city, and we have city value, or we don't. We create one. We did create one city. So let's see. Yeah, we have city. Okay. So we should get. Oh, of course, this is going to be a string. Okay. It's not a call. It's just the function creation. So for URL string, right? And we're gonna have a string supplied here. Okay, this is basically gonna be the place where we're gonna make our network call. So we're gonna say network manager, and we're gonna provide the type here. So we're gonna say the T type is gonna be weather response. Okay, and we're gonna call fetch on this. Okay, fetch takes a URL. Okay, so we're gonna construct that URL, and the string is going to be the URL string that's being passed. And we're going to force on wrap because we know our URL string is always going to be there, because we're going to create a default case as well if the coordinates are not present. Okay, now this gives us a result like we created. The network manager gives us a result. So we're going to put a switch statement on result itself. Okay, and we're going to say there are two cases. There is a success case and failure case. Success case provides us a response, and we want to move to the main thread and set our weather object that we have, the published object that we have at the top, set that with the response that we have received. Okay, so that is our case for success. For failure case, we're gonna get error, and we're gonna simply print the error like so. Okay, so now if we go back into our get weather call, we are simply going to say get weather internal. Okay, we're gonna pass our city, although I don't know if we're gonna use that, but anyways, we can pass it if we need to use it, or if you see a case where you want to use it. For the default case, if the coordinates are not there, in that case, what I'm going to do is I'm going to just use a random coordinate, and I'm just going to provide that. Okay, and what we're going to do is we're going to say get weather internal info for city and the URL string that we have used. All right, so this is basically our network call that's actually gonna be calling the API and getting the response. Now, where are we gonna call this? So we're gonna call this on location. So we need to create a function to get the location. Remember that placeholder that we created, get location? We're gonna create that function now. So we go ahead and create private func get location. That doesn't take anything, and this get location is going to use CLGO coder. Okay, going to create an object for that, and this has a function called geo address string, which takes city and the completion handler. So we're going to supply the city here, and it returns us place marks, which is basically a collection of places that it thinks like that can be part of that location. So if San Francisco is more than one, like it's gonna give us a collection of those place marks. Okay, it can also throw us an error, so or return us an error object or like any completion block. So what we're gonna do is we're gonna say if we can get places from place marks, right? And we can get a place, so the first object from places.first. So if we can get those two, right? Then we're gonna simply say self.get weather, and we're gonna say place.location.coordinate. So we're gonna call our get weather here, which is gonna provide the coordinates. If the object is nil, then we're gonna use the default coordinates, and that's how we're gonna basically make our convert our address string, the string that the user has entered, for example San Francisco, Paris, London, whatever, gonna be converted into coordinates. Okay, it uses internal API that Apple provides or iOS itself provides. So we're gonna, during the initialization, we're gonna call this, and whenever the city is set, we're gonna call this function as well. Okay. All right. So let's go ahead and just a couple more things that are left. There are two functions. So I want to copy and paste because those two are pretty static in nature. So I'm gonna copy and paste those two, and we're gonna talk about what those two functions are. So there's one that is get Lottie animation first, a helper function that we're going to create in our view model. It is going to return Lottie animation name based on the icon that's been returned by the API response. So once again, let's go back to the API, and if you notice, the weather detail gives us an icon in form of these codes 0, 1, D. D represents for day and represents for night, and then these are like different cases. So when the first one comes, it's a day, clear sky, and so on. So what we're going to do is we're going to create a JSON, Lottie animation JSON inside these this folder. Not create, but download and copy them and change their name to represent these. And whenever this icon is requested or supplied, we're going to give that name, the name of the file, Lottie animation file, back. Okay, and that's going to make it possible for us to show that particular animation for current weather condition. So that's actually for all the cases. Then you have get weather icon, which is pretty similar. So you get your weather icon code and you convert it into an image. We're gonna use SF symbol in this case, and we're gonna return some value here. Now this one is going to be used for hourly weather forecast and daily weather forecast. So those two places we are showing just an icon, not animated image. So that's why we're going to use these. For the animated image, we're going to use Lottie animation. All right. With that, our view model is complete. Okay, so let me go ahead and scroll through slowly here just to show you all the cases. Okay, so yeah, with that, our Lottie animation is complete. So what we're gonna do next is we're gonna, or not Lottie animation, our city view model is complete. So next we're gonna do Lottie animation. So we're gonna go ahead and include Swift Package Manager dependency basically for Lottie, and we're gonna create our Lottie view, and also gonna look at the place from where we can get the Lottie animation. So you can download those, rename those, and then start using them. So that's going to basically prepare us to create views inside our for our app. Okay, so that's what we're going to do next. All right, so what we're going to do is next we're gonna include Lottie animation into our project and create a Lottie view. Now if you're not familiar of Lottie animation, it's basically a library that was created by Airbnb, and what it does is basically it takes JSON that's written, I guess, in Illustrator or something, or some sort of animation software, um, and it basically converts that. After Effect, yeah. So After Effect uh, animation created, so you use After Effect to create the animation, and you can convert that into a JSON file, and then what you can do with it is you can basically simply take. So this one is definitely not free, so we gonna need the one that is free. So if you notice, the one that has download symbol, that those are free. So I'm gonna show you like how they look like. So you can download like GIF, download JSON, and yeah, so you can control animation speed, background colors, and stuff like that. So what gives you is basically it gives you this animation, this complex animation that can be controlled by your Swift code, and then you can just include it and start using it. The one that I'm using in particular, that one is from this, let me see, this one. Yeah, so this is the author Adriana, and she has created some of these, so I'm using hers, and all of these are free, so you can go ahead and download those. And so just look for Adriana, and you will find these, and you can just download these animations. So just click on this and download JSON. That'll actually download it, and you'd have to rename these files. Now, as far as the library itself goes, you're gonna have to come to Airbnb/Lottie iOS, or search Google Lottie iOS, and you'll find it. And basically, this has like all the details. I didn't. I don't think I did a good job like explaining what it is, so you can go ahead and read about it here. But yeah, if you scroll down, there is a CocoaPod version that you can install if you're using CocoaPod. There's a cartridge, and there is Swift Package Manager. So what we need is this link right here. So I'm just gonna copy this link, and gonna go. So let me minimize this, and gonna go to my project, and then select Xcode. Sorry, File, Swift Package, Add Package Dictionary or repository, and I'm just gonna paste that link right there, and gonna click next. It's gonna pick up the version, so you just say like this is the default version, yes, this is what we want, that's the latest, and click next. It's gonna basically resolve that dependency, and gonna include it in your project. So let's wait for it to. Okay, so there we go. Now we need to just click finish and we have our dependency added. Now on this page, basically you can, this is your page for your app target, info and Swift packages. You can come here and you can add and remove dependencies and stuff like that. Or you can go to file, add Swift package, add package dependency, and then add a new package dependency right there. Okay, just like we did. Okay, and this is it. Like, this is all you need to do basically to include your new dependency, external dependency, and your dependency is going to be resolved here. So there is no pod install and stuff like that needed. Now, what you need is basically a view. So let's create a view for Lottie, and I'm going to create a new file here. We're going to call select Swift file and going to call this Lottie view. Okay, and Lottie is basically is still is not written in SwiftUI, so we have to write a SwiftUI version of this, which we can do using UI view representable easily. So first we're gonna import SwiftUI, then we're gonna import Lottie, and then we're gonna create a struct Lottie view UI view representable, and then these are the parameters that we're going to expect when user is creating this view. So we're going to expect the name of the animation. Okay, so name of the animation. We are also going to expect loop mode. So this is Lottie loop mode, and we're going to say by default it's actually going to be on loop. Okay, and there are two method requirements that you need to override. Make UI view. This is where we create the view. So we're gonna say view is equal to UI view. Return view. Okay, and the view type is gonna be UI representable. View representable. Context of type Lottie view. Okay, so that's gonna be the context, and then we're gonna have update view. That's another required. So whenever state changes, at that time your view receives updates, and this method is called. So we're gonna use this method to basically um, uh, set up or set the properties for our Lottie animation. So here what we're going to do is we are simply going to first look at UI view dot subviews dot for each. Okay, and we're going to go through for each subview, and we're going to remove them from super view. Okay, that's going to be the first thing, because we are resetting all the state, right? Because state has changes, our animation might have changed, so that's why we are doing this. So we're going to simply say let animation view is equal to animation view. This is animation view comes from Lottie animation itself, or Lottie library itself. So animation view dot translate auto resizing mask to false, and then you add subview animation view, and then you activate constraints, So we're gonna constrain to the height of the view and the width of the view. Okay, and then we're gonna simply say animation view dot animation is animation dot named animation view dot content mode scale aspect fit loop mode is our loop mode and animation view dot play. Okay, let's go ahead and try to build. So our build succeeded. So this is all what we need basically to create our Lottie animation. So now whenever you're ready to use the Lottie view, all you need to do is you need to create this Lottie view and supply the name of the animation that you're gonna play, and that's it. Like you would be able to play that animation, and it's gonna be by default it's gonna be running in loop. um, so let me go and take out the animations, and I'm gonna include the animations inside my this Lottie animation folder from my previous project. So I'm just gonna copy item if needed, and these are going to be the animations that we're going to be using. So if you click on one of the animation, what you're gonna see is like bunch of JSON. All right. So that's what you see inside your Lottie animation file. But we are done with our Lottie animation and or Lottie view, and we are ready to play Lottie animation inside our project. So up next, we're gonna start setting up our rest of our views. So we're gonna start with, like, all the sub views, and then put together them inside the main view, and then populate our content view, and then we're gonna try to run the app. Okay. All right, so let's go ahead and create our first view, or like maybe our second view. We're gonna call this one menu header view. This is basically the search bar. So we're gonna select SwiftUI view, and I'm gonna call this menu header view. Okay, and what we're going to do is we are going to first of all create an observed object. So we're going to be receiving observed object of type city view model. So we're going to simply say city view model, city view model, and we are also going to manage a state variable for searched city. So search term, and I'm gonna set this to San Francisco by default. Okay, and for the body part, so for this we can simply say it's content view. All right, for the body, we're simply gonna say h stack, and this h stack is going to have a text field. Okay, this text field is going to be bound to the text in search term. You're gonna add some padding in leading direction for 20 points. There's also gonna be a button. Now this button is going to act, so we're gonna use trailing closure, new feature, double trailing closures. So we're gonna say city viewmodel dot city is equal to search term, and then label is the other closure, and here we're gonna have z stack rounded rectangle corner radius about 10 points, fill, color dot blue. We're going to use system image, system image, system name, location dot fill. So this is SF symbol image named location dot fill. That's what we're going to use. And then we're going to provide a frame to this with 50 points. So the frame is to set the width and height for the button. Okay. And then we're going to set some modifiers for HStack itself. For example, the foreground color is going to be white. Let's add some padding. Give it a background. Now background is going to be a Z stack with alignment as leading. And here we're gonna basically put an image for magnifying glass. So once again, system name, magnifying glass is the image name, SF symbol image name. Let's give it a foreground color of white, and we're gonna give some padding to it in the leading direction. We're also going to have a rounded rectangle with corner radius about 10 points. And we're going to give it a fill with color dot blue dot opacity 0.5. Okay. All right. So that is our menu header view. Next, let's go ahead and create our city name view, which is going to have the name of the city and the date. Okay. All right. So let's go ahead and create another file, another SwiftUI view. We're gonna name this one city name view. Okay. And this guy is going to take city as a string and date as a string. So two parameters while initializing it, and then we're gonna have simply an H stack, which is gonna have a V stack, and this V stack is going to have alignment, center, and spacing 10 points. We're gonna have a text for city with font title, make it bold, foreground color, we're gonna set the foreground color to white, and we're gonna move this to VStack level so we don't have to define the foreground color for other view, which is date. Okay. All right. Here I'm just gonna change it to content view. Okay. All right, so this is it. This is our city name view, and this view is going to show the name of the city and the current date. Next, we're gonna create our today weather view, which is gonna basically display today weather. So as you can see, like how we are creating smaller views, and this is helpful because then we can put these views together to create a complex view, and our file does not grow really long, and our code basically stays in check. I mean, there's not too many things going on where we don't understand. It's difficult to where it's like difficult to refactor. This is easy to refactor. You can change any of the design, and your code is still gonna work. Cool. So so let's go ahead and create today weather view. All right. So next we're gonna create our today weather view. So let me go ahead and pull the app up. So this is what we're gonna do. Basically, we're gonna create this widget right here. Okay, and we are going to be creating a function that will create these views. So all we need to do is supply the image, the color, and text, and then we'll get a view so we can render it. Okay, so I've already created a file, today weather view. So what I'm going to do is I'm going to create a private function here called widget view. This widget view is going to take an image as string, and we're going to be using SF symbol images. So that's why we are actually expecting an image string. We're going to expect color and title. Okay, and this function is going to return some view. All right. Now what we're going to do is we're going to create a VStack. Inside that VStack, we're going to create our image with system name, and we're going to give it a padding, font, foreground color, background, and we also gonna have our title text. Okay. All right. Then what we're gonna do is now we're gonna construct our today weather view. So so for today weather view, what we're gonna do, first thing we're gonna need is an observed object of city view model. Excuse me, city view model, and for the body, we're gonna create a VStack with spacing 10 points. First thing we're gonna have is a text. We're gonna say today. Let's give it a font and make it bold. Then we're gonna have an edge stack. This edge stack is gonna have a spacing of 20 points. And this is where we're gonna use our Lottie view. So we're gonna just call Lottie view. And if you remember, Lottie view takes two overloads. There's a name and there's a name and loop mode. We are going to use the name, and we are going to call our city view model dot get Lottie animation for icon, and we're gonna say citybm dot weather icon. Now there is one modification that I did inside the view model, so let me show you that. In the view model, I was earlier returning an SF symbol key or string, but we are using Lottie animation, and there is no SF symbol, so our files are different. So what I did is I changed that into the Lottie animation, the default Lottie animation. So if the icon is not found, or this section is less than 0, then we're gonna return the default icon. Okay, so that's the weather icon. So we're gonna get that, and that's gonna get the name of the animation that we're gonna use for this Lottie animation. We are also gonna create our frame, and we're gonna define width and height. Not 10, it's gonna be 100, and we're gonna rely on default alignment, so we don't need the alignment object. Now next we're gonna create a VStack with alignment of leading, and we're gonna show two text properties or text views here. First one is going to be our city view model dot temperature, and we need Fahrenheit symbol, so all you need to do is press Control Command Space, and this is your emoji selection. And if you look for Fahrenheit. Okay, I can't spell Fahrenheit. Let me look for the spelling for Fahrenheit. All right, let's try it again. So I'm gonna try Fahrenheit, and there we go. All right. So that's going to be the Fahrenheit symbol, and then the next text is going to be your city view model dot current conditions. So conditions. Okay, let's give this a font. So the temperature, we're going to give it a font of system size 42. Okay. Then we're going to create an H stack. This is going to have spacers, so we're going to center align our views, and we're going to call our widget view function that we created, and we're going to start supplying images. So first one is going to be wind, color is going to be green, and title is going to be city view model dot wind speed miles per hour. So 9 miles per hour, 10 miles per hour, space, etc. like that. Okay, another spacer, widget view, image is going to be drop.fill for humidity, color is going to be blue, and we are going to have city view model dot dew dot humidity actually. Okay, another spacer, and then we're gonna have our widget view again, umbrella dot fill, and color is going to be red, and title is going to be city view model dot rain chances. Okay, and yeah, so that's our bottom section basically, and this is all we have for our today widget. So let's go ahead and give it some more modifiers to make it look a little bit nicer. So what we're going to do is we are going to provide, so let me see. All right, so we're going to give some view modifiers to this v stack. Okay, so basically this is going to be for our entire view, the background and stuff. So we're going to say padding, foreground color is going to be white, background is going to be a rounded rectangle with corner radius 20 points. Fill is going to be linear gradient, and we're going to create a gradient object. And for the colors, so let's fix this, content view. Okay, for the colors it's going to be color dot blue dot opacity, and we're going to give it opacity of 0.5, and there's going to be another color dot blue. Starting point is going to be top, and ending point is going to be bottom. Okay, and we're going to use just these two colors for our gradient, and then we are going to have opacity for entire thing of 0.3. Okay, so this opacity is going to be applied on the rectangle itself, for the, let's see, for the linear gradient actually. So this is where our rounded rectangle is ending, and this is where our linear gradient is ending. So we are actually applying opacity on the linear gradient. Okay, now we're going to give it a shadow, and we're going to use the other overload for shadow, and which is going to be color dot white. Opacity is going to be 0.1. Radius is going to be 2. X is going to be -2, and Y is going to be -2. I'm going to copy and paste. There are a few things that we're going to change. So this is going to be black, 0.2, and these two are going to be positive values. All right. So this is it for the today's widget. And next we're going to create our hourly weather view. Okay. All right. So let's go ahead and create another view. So I'm going to create a SwiftUI view. We're going to call this one hourly weather view. Okay. And let's modify this to be content view. We're going to have observed object. For the body, we're going to have a scroll view. Right, and the scroll view is going to have horizontal direction, shows indicators, it's going to be false. We don't want to show the indicators. And then inside this we're going to have an H stack with spacing of 20 points. Okay, and what we're going to do is here we're going to for each into city view models weather dot hourly, and this is going to give access to individual weather. So weather n, and let's get weather icon first. Call it icon city view model dot get weather icon for weather dot count greater than 0. So if there is something, then we're gonna say weather at 0th index dot icon. If it's not there, then we're gonna say give us sun dot max dot fill. That's the default. Okay, so that's the icon. Then we're gonna have our CityVM dot get time for, and timestamp is gonna be weather dot dt, and temperature is gonna be CityVM dot get temp for, and we're gonna say weather dot temp. Okay. Now we need a view that's gonna a cell that's gonna display this. So let's go ahead and create a function, a private function, which is gonna be getting this or constructing this view for us, and we're gonna supply our image and temperature for us. Okay, temperature is going to be a string. Okay, going to return some view, and we're gonna create a view stack with spacing 20 points with text our image dot foreground color is going to be yellow, and text for temperature. Let's give this, set this some modifiers for this. So set the foreground color, padding, background, corner radius is going to be 5, fill is going to be a linear gradient, so it's going to have specific shades of blue. That's what we are going to use. So let me go ahead and paste that linear gradient. Okay. All right. So it's just same linear gradient. I'm using these specific colors. So if you go take the color palette and let's see if we can find the color hash. Okay, so this is the hex color value. Okay, so that's what we are using. So this is the first one, and this is the hex value for the second one. Okay, all right, and then we are going to need some shadow. So I'm gonna say shadow. Gonna use the color over second overload color dot white. So this is actually going to be same as the shadow that we have created in our today. So I'm going to simply copy those two and paste it right here. Okay. Right. So then we are ready for our cell. So we're simply going to say get hourly view, and we're going to supply the stuff that it needs. So image is icon and temperature is temp. Okay, let's go ahead and build to make sure everything builds. All right, so this is your hourly view. Next up is going to be the daily weather view. So let's go ahead and take a look. So we have done this part right here. Now next up is this section where we're going to show the daily weather forecast. Okay, so that's come. Okay, so let's go ahead and create a new view, and we are going to call this one daily weather view. Right, and our daily weather view is going to have a first of all, let's fix this. So content view, and we're gonna have once again observed object being passed. Okay, and what we're going to do basically is we are going to go over and for each inside city view model dot weather dot daily, this will give us access to individual daily weather type. Okay, so weather in, and we are going to create a lazy v stack. So let's create a lazy v stack. Okay, and we need to create some sort of cell here. So let's go ahead and create a function. We'll call daily cell. Weather is supplied of type daily weather, which is going to, this function is going to return some view. We're going to have an h stack with text in it. And we're going to give this a width of 15. Okay, then we're going to have a spacer, and next to it we're going to have a text for temperature. So city vm dot get temp for weather dot temp dot max. Gonna gonna have a pipe symbol, and then we're gonna have city vm dot get temp for weather dot temp dot min. Okay, and once again we're gonna use our Fahrenheit symbol right there, and we will give this a frame width as well of 150. Then we're gonna have a spacer, and then we're gonna have cityvm dot get weather icon for weather dot weather hero dot icon. Okay, Now here also, what we can do is we can put that condition. So weather dot count is greater than 0, then return this. Otherwise, let's see, get weather icon, I think. Yeah, sun dot max dot fill. Okay, so that's going to be the default in case the value is nil. Foreground color is going to be white. Padding is going to be in horizontal direction, 40 points. Padding in vertical direction is going to be 15 points. Background, so for the background and shadow information, I'm gonna copy this guy right here and paste this. So I guess, like, one of the things I want to say is if you like and if you want to create sort of like an extension, not an extension, a view modifier to set the background, then you take this as a challenge and create yourself a background with this shadow and convert it into a view modifier so you can apply it wherever you want to have this kind of shadow and this kind of background with look and feel. Okay. All right. So with that, I guess we are done with our daily view. All we need to do is make sure we call our daily cell here and supply the weather. And this is basically going to create our daily cell. Okay. So next is basically our city view, which is going to use some of these views and going to construct the entire city view. And then we're going to jump on to content view, which is going to basically lay out all the fields like search and city views and stuff like that. Okay, so okay. So let's go ahead and create our city view. So I'm going to create a new file. I'm going to call this one city view. Okay, and city view once again is also going to receive an observed object of city view model. So as you can see, like none of these places we are actually creating city view model. We are actually using what's being supplied to us. Okay, and what we're gonna do is we're gonna create a VStack. First, we're gonna show city name view. And for the city name view, it takes city. So we're going to simply say city vm dot city and city vm dot date. Okay, so this is going to give us the city view. Then we're going to have our today weather view, and we're going to supply our city view model during the initialization, give some padding. Then we're going to use our hourly weather view and apply the city view model as well here, and daily weather view, same thing. And let's give padding at the bottom of 30 points. And that's about it. So we're going to call content view here on the previous. And yeah, that's about it. That is our city view. So let's go ahead and hop into our content view, and we're going to create the one final screen and gonna build the project once again. All right, so let's go ahead and create our go to our content view. So I'm going to collapse everything, and our content view is already there. So we're simply gonna go into the content view, and this is where we're gonna actually create our observed city view model object. So we're gonna say city view model is equal to city view model, and we're gonna initialize it here. And from here, it's gonna be used by everyone else. And now we're gonna create our Z stack with alignment bottom and we're going to create a VStack spacing. We're going to give it 0. Then we're going to use our menu header view and going to supply our city view model. Then we're going to have a scroll view. Shows indicators is going to be false. And inside this, we're going to call our city view. So as you can see, with the views already built in, how easy it is for us to just take everything and put it together. So for the background, I'm going to use that linear gradient that we have used with those static colors. Okay, so that's going to be the linear gradient, and I also want to set edges in ignoring safe area dot all. Okay. All right, so now let's go ahead and build and run and see if we can get ourselves the view like this, the weather view loaded. Okay, so it's going to take a minute, so let me go ahead and pause the video till the time it comes. All right, so it's loaded, and as you can see, this is our weather view, and we have a bit of this spacing problem. So at the top, I need a little bit more padding. So I'm gonna say, let's give it a 40 points and see if that makes any difference. Okay, it did a little bit, and this V project is showing up. So let me go ahead and, as you can see, my computer is running super slow. But yeah, so this is our weather view, and oh wow. Okay, so my computer is like super slow right now. Let me see if I can close a few things. Just hang on 1 second. All right, so let's try it again. So I'm gonna build and run again. And okay, so we are getting a so there is no response. So everything is empty, and we are getting invalid response. At least our animation is working. Okay, so that's good. All right, so let me see if I think we need to check HTTP API. Okay, this is one call, so let me go ahead and run this again. And okay, so now we are getting another key did not found feel like. So I guess there's some key mapping issue. So let me see. Let's go to our model. And let me check what the model is supposed to look like. So I think it feels like. Yeah, okay. Although we are not using feels like, but in case if you would like to use that. All right, there we go. So we have our model being populated. As you can see, our animation has changed because there are some clouds in San Francisco today. So it seems like that cloud is sort of displaying the animation. The correct animation is being rendered, and this is our 7-day next 7 days or next 8 days of forecast, and this is our hourly forecast. Okay. I guess the other thing that we need to check if our search functionality is working. So let's go ahead and search for Fremont, and let's go ahead and search for San Jose. Okay, so okay, yeah, so that's good. Let's go outside the United States. Maybe let's go New York. Okay, so it's snowing in New York. There's a snow, and our snow animation is looking pretty cool. One thing I do notice here, there's this bit of a a spacing problem. So let's go ahead and fix that. So what I'm going to do is menu header. So let's go ahead and give this a little bit of padding at the top. Let's say 10 points. And let's go ahead and give some padding to this guy as well. And see what happens there. Okay. That is looking a little bit better. Okay. All right. So let's go ahead and search for London. Okay. London is cloudy. And let's go ahead and check out maybe Auckland, New Zealand. So there's sunny right there. Okay, let me see if I can find a place where it's night. We can see night animation. Okay, so there's New Delhi. It is night. Let's see, maybe Bombay. Okay, let's check out Mumbai. Same. Okay, so yeah. All right. So yeah, so this is it. So I was just making sure all of our animations are working okay, and night and day are being rendered properly. But yeah, as you can see, our weather is being um, printed and rendered properly. Our daily and hourly weathers are looking great. So yeah, this is about it. We created the entire weather app from scratch with animations, and we actually learned a whole lot. So yeah, this is it for this video series. So thanks again for watching and your ongoing support, and I will see you guys in another series. Thank you.